Hi guys, so got the hang of getting this video going. Was able to plug it into my computer so that I could have um, my iPad showing and I can actually do the work on here for you guys. So I've taken problem 5 from the Law of Cosines homework and let's work on it together so that you guys can see how you're using both the Law of Cosines and the Law of Sines to solve for a triangle. So if you remember, your law of cosines is your a squared is equal to b squared plus c squared minus 2bc cosine of a. And let's get some parentheses going in there so you know where the c ends and the cosine begins. And if you remember, we talked about bookends. So here are my bookends. So if we take a look at the triangle we're going to start with, so on number 5, see that we have an SAS triangle. That means that we're going to want to solve for that third side, which is across our angle. So we're solving for this side here. We'll call that N. So that means that here are my bookends. Okay, and the rest of my values are what's going to fill in the middle. Okay, so let's get this going. So we're going to have our N squared is equal to my other two sides. So 10 squared plus 13 squared minus my 2 times 10, and then 13. And then we have the cosine of 112. So again, here are our bookends. And then the rest of our stuff in the middle. All right, so let's simplify this a little bit. So we're going to have 100 plus 169 minus, that's 130 times 2, so that's 260. And then cosine of 112. Okay, the only thing I can simplify right here now is adding those two together. I cannot combine my 260 cosine of 112 with what I'm going to get for this, which is 269. Okay, so we're just going to carry this down. Okay, so we have simplified as much as we can. Now we need to solve for n. So to solve for n, we're going to take the square root of both sides. So n is going to equal the square root of all this stuff. Okay, so when you plug that into your calculator, you should get that we end up with n as 19.1 when we round it to the nearest tenth. Okay, so that's our n. So let's add that up here. Okay, so if you recall from there, so this was part 1. From there, we need to use the law of sines to solve for one of our other angles. And we want to go and solve for L next. Okay, so law of sines, remember, is your sine of A over A is equal to sine B over B and sine C over C. So we want to set up two ratios, and one of those ratios we do not want to have a variable in. So we're going to set up our sine of L over 10 because that's the opposite values there. And then we'll use what we found, which is our 19.1, and then with our sine of 112. So let's set this up. So we're going to have sine of L over 10. Okay, so this is step 2, is equal to sine of 112 over 19.1. So we can think of multiplying on both sides by 10 to get rid of that 10. So it goes away here. It's going to leave us with sine L is equal to 10 times sine 112. And then we have 19.1. Now recall, when you solve for an angle, we need to take the inverse of both sides. So we're going to take the inverse of both sides. Canceling that out there leaves us with sine inverse of 10 sine of 112 divided by 19.1. So when you guys plug that into your calculator, you will have the measure of angle L is equal to 29 degrees, rounding up to the nearest degree. So there's our measurement for L. And then to find M, well, we're just going to take our 180 and we're going to subtract what we have. And that's going to give us our M, which is 39 degrees. And so we have completed our triangle. Okay. So let's take a look at one other problem. Let's do problem 8. This one has, we're dealing with an SSS triangle. Okay, so recall that when we are working on an SSS triangle, we are going to use the law of cosines first, and we specifically want to find the largest angle first. That means that we are going to be solving for D. So those are going to be our bookends right there. Okay, so to set this up, we're going to start with 6 squared is equal to, now here are the other sides, so that's 5 squared plus 4 squared minus 2 times 5 times 4, and that's going to leave me with the cosine of D. Okay, so we have our bookends, and then our other sides in between. All right, so let's evaluate this thing. So it's going to give us 36. That's our 25 plus 16 minus 20 times 2 gives us 40. And our cosine of D. Okay, so we keep simplifying. We can simplify these two right here. So that's going to give us 25 plus 16 gives us 41. So 41 minus 40, cosine of D. Okay, these here cannot be simplified anymore. But we can take this 41 to the other side, because those are like terms. So on this side, we end up with, what's that? That is a negative 5. And that's going to equal our negative 40 cosine of D. Okay, we need to get cosine D by itself, so we're going to not subtract, we're going to divide by negative 40. So we end up with 5 over 40, because a negative and negative is positive, is your cosine of D. And since we are solving for that angle, we have to take, we have to take the inverse of both sides. So we end up with our cosines, leaving us with D. And this is cosine inverse of 5 over 40. So the value of our angle D, once we plug that into our calculators, is going to give us 83 degrees. Okay, so there's our D. And then we have to go and use the law of sines. So again, here's part 1. We go and use the law of sines to solve for our other angles. So let's solve for F. So law of sines. So part 2. Part 2 for number 8. So we're going to start with sine of f, because that's what we're looking for. And its corresponding side there, opposite, is 4. And I have the value of d and its side, so that's going to be my other ratio. So I'm going to have sine of 83 over 6. We do some cross multiplying, or we can get rid of that 4. So that's going to leave us with sine of f is equal to 6 sine 83 over 6. And then, since we're solving for the angle, you have to take the inverse. So we end up with f is equal to sine inverse of all this stuff in here. Okay, so plugging that in and calculating our measurement for f, we end up with f being 41 degrees. So we have f as 41 degrees, and using the fact that all the angles in the triangle are going to add up to 180, we have the measurement of E at 56. Okay, so I hope that's kind of helped out with those two problems and kind of guide you on how to use the law of cosines and the law of sines to solve for a triangle. The other thing that I kind of wanted to go over, because I know you guys love drawing pictures, let's take a look at number 9. So number 9 is telling us, after fielding a ground ball, the pitcher, who's located 110 feet from first base and 57 feet from the home plate. So the distance from home plate to first base is 90 feet. We want to know what is the measure of the angle with its vertex at the pitcher. And then we want to round that to the nearest degree. So if we think about a baseball field, okay, so we have home base up here. And when somebody hits, they're going to run, and go to first base. And then, of course, they run and go to second. But if we think about the pitcher, because our pitcher's involved, so more or less there's kind of our triangle. So you have your home plate, your first base, and then the pitcher's mound. Okay, so let's add some values in here. So a baseball pitcher is located 110 feet from first base. So that's my 110. And 57 feet from our home plate. Whoops, got that 110 the wrong place. The pitcher, so the pitcher is over here. And I don't play very much baseball, as you can see. And then home plate, we have 57 feet. Okay. And let's see, the distance from home plate to first base is 90. So this is our 90 there. And we want to know this angle with the vertex at the pitcher. So we have to solve for this angle here. So setting up our law of cosines, you're going to want to remember your bookends. So P is what we're going to be looking for, and 90 is our bookend. So those two are your bookends. So kind of just starting you off on the equation, you're going to have 90 squared is equal to your 110 squared plus 57 squared minus your 2 times your 110 times 57, and then the cosine of P. So I'll let you guys have fun with that and calculating that out, but that's kind of how you set up those triangles there. And let's see if there's any other one I wanted to go through.